In this lesson we're going to look at temperature scales and the unit for temperature. So imagine that in the Middle Ages, 1066 for example, somebody asked you, what is the temperature today? Well, you'd have been fairly limited in the way that you can reply. You might say, for example, it was very hot, mild, cold, or absolutely freezing. Now, the problem with this is it's not really very scientific. So clearly, as times advanced, people needed a more accurate means of deciding what the temperature was, particularly scientists. So it wasn't really until the beginning of the 18th century that we got our first recognized scale for temperature, or unit for temperature, which is the Celsius scale. And Celsius was a Swedish scientist, and he realized that he could make use of the properties of water in order to define his temperature scale. He decided that the 0 point on his scale, let's call that 0 degrees Celsius, would be the temperature at which water freezes, or the melting point of ice, and that he would make the temperature at which water boils 100 degrees Celsius on his scale. So it's important to note that these two values were arbitrarily chosen. So the melting point of ice isn't 0 by some strange coincidence, or the boiling point of water isn't 100 degrees Celsius by some magical coincidence. These were actually arbitrarily decided by Celsius to be the reference points on his scale. And so all you've got to do then is divide your scale up into 100 intervals, and you've got the value of the degrees Celsius defined by the boiling point and melting point of water. Now then, you'll notice that this scale also allows us to have negative temperatures. So temperatures can go well below the melting point of ice. Now, that creates a little bit of a problem, because if you remember in our last lesson, we learned that the temperature of a substance is directly proportional to the average kinetic energy of its particles. Okay, so the problem with this is that you cannot have a negative value for the average kinetic energy. That is to say, the lowest kinetic energy that a particle can have is 0. You can't have a negative kinetic energy. You can't have a negative amount of movement. The particle can't be moving any slower than it is when it is stationary or motionless. That is the absolute slowest that it can be. So Kelvin realized there must be what we call an absolute 0 for temperature. That is, a temperature at which all particles stop moving, and he called that absolute 0. So he introduced a new scale which became known as the Kelvin scale, and on his scale, well, he defined a point which is the lowest possible temperature, which is called absolute 0, and on the Kelvin scale that is given 0 K. No, there's no degree sign here, it's just 0 K, 0 Kelvin, and 0 Kelvin on the Celsius scale occurs at approximately minus 273 degrees Celsius. So that's a very cold temperature indeed. So at that temperature, all particles stop moving altogether. They have 0 average kinetic energy. Another important thing to point out that in both scales, the Celsius and the Kelvin scale, the interval for temperature is the same. That's to say, a change of 1 Kelvin is exactly the same as a change of 1 degrees Celsius. They are identical. So the intervals are the same. So if absolute 0 occurs at minus 273 degrees Celsius, then clearly, we'll put it up here, the melting point of ice will occur at 273 Kelvin, and the boiling point of water at 373 degrees Kelvin. So if we want to move between the two scales, for example, if we're given the temperature in degrees Celsius and we want to find out the temperature in Kelvin, then all we have to do is subtract 270 degrees Celsius. That's to say we have to shift by either plus 273 or minus 273, depending on which way we want to go. So if we're given the temperature in Kelvin and we want to find the temperature in Celsius, then we just take 273 from our value. So we're told that the melting point of iron is 1811 Kelvin, and you want to find out what that is in degrees Celsius, then it'll be 1811 minus 273, which will give you 1538. So that's equal to 1538 degrees Celsius. Conversely, if we want to go from Kelvin to degrees Celsius, then the temperature in Kelvin will be equal to the temperature in degrees Celsius, this time with a positive shift of 273. So we're told that the melting point of tin is 232 degrees Celsius, and we want to find out what that is in Kelvin. Well, that will be equal to 232 plus 273, which is 505. So that will be equal to 505 Kelvin.